We're going to look at series and parallel circuits today. And this is going to be probably the core of your calculations and the core of your electricity uh, questions that will come up in your AS exams or maybe even your A-level exams. So I'm first going to draw a series circuit. So if I have a battery, let's say about 50 volts is being supplied. I'm going to put an ammeter and we have two resistors. Both of them are ohmic conductors. All resistors you can assume in your questions in your exams will be ohmic conductors unless specified otherwise. So this means that they will follow V equals IR and will have constant resistance. So let's say R1 has a resistance of 30 ohms and R2 has 20 ohms. Draw up the circuit, and let's say we put two voltmeters which you know are placed in parallel with each resistor. Now, for series circuits, there are some properties that you need to know. So firstly, the current will stay the same throughout, and voltage will get shared. Because current is constant, and you know V equals IR, V is therefore proportional to R. So voltage is shared in the ratio of the resistances. Now, one thing you need to make sure when you're applying V equals I or doing your calculations is that you're using the correct voltage for each component. In this case, it says 50 volts as the battery supply. Now, if I asked you to work out the current flowing through the circuit, and you might think, okay, let me use V equals IR, and you think, okay, I is therefore equal to V over R. Well, the total voltage is 50, and we know one of the resistance is 30 ohms, and you might think that's your current. That's a very common mistake, more common than you actually might believe. And in this case, you might realize, okay, that's quite easy. But as circuits get a little bit more complicated, these mistakes can easily happen. You need to understand that in this case, when you're taking the current, we are here using the total voltage in the circuit. So therefore, you must use the total resistance. And in this case, the total resistance is not 30, but 30 plus 20. So in this case, the current flowing through the circuit is 1 amp. You need to make sure that if you're using V equals IR, if you're using the voltage across the whole circuit, you need to use the total resistance. If you're using the voltage across one component, you have to use the resistance of that one component only. Now in series circuits, when it comes to resistances are added linearly. What that means is the total resistance in the circuit is equal to R1 plus R2 plus R3 and so on. In this case, there are only two resistors. So the total resistance in a series circuit in this case is 30 plus 20, so that's 50 ohms. That's the total resistance of this circuit. And resistance calculations can be very handy because instead of trying to find out the individual voltage and current through each component or through each junction, it might be a lot easier to just work out the total resistance of a section or the whole circuit and then use one V equals IR equation, or maybe two. Resistance calculations can be very, very helpful and handy and could save you a lot of time in your exams. Now, one little trick that you can use for series circuits is something called the potential divider. Let's say I had a battery with 16 volts. If I had a current flowing through, so we put an ammeter, and let's say I had two resistors, one this time is 100 ohms and the other is 60 ohms. Now let's say I wanted to find out what is V1, the voltage reading on the V1 voltmeter. So what is V1? Now one way you could do this is to use V equals IR, find the current, and then substitute to find the voltage. And let's try that first. So I is equal to Vt over Rt. Remember, we have to use the total. We're only given the total voltage, so we have to use the total resistance. So that's just a linear combination of the two. So that's 16 volts. Let's ignore the units for now. When you're using the calculations, it's probably best not to put the units in the equations. So I'd say 16 volts over 160 ohms in total. So that's 0.1 amps. And then if I wanted to find V1, I could say V1 is equal to I times R1. And remember that the current in a series circuit is the same throughout. So the current through the whole circuit is equal to the current through R1 and the current through R2. So the current through the 100 ohm resistor, through the battery, and the 60 ohm resistor is all the same. So in this case, you're getting 0.1 amps times by 100. So the voltage across this resistor is 10 volts. And one shortcut that you can use is something called a potential divider, which is basically a manipulation of the ratio method. I said before that voltages are shared in the same ratio as the resistances. So we can say V1 is equal to the resistance of the 100 ohm resistor, or R1, over the total resistance times by the total voltage. This means basically what this is what fraction of the resistance you're finding of the total resistance times by the voltage of the total circuit. Now this can also work for, let's say, if you knew the voltage across, let's say, the 60 ohm resistor, R1 over R2 times V2. If you knew the voltage across 60 ohm resistor, we could call that V2 and use the ratio method with R1 and R2 to work out V1. But at the moment we don't for this circuit, so let's just stick to the first potential divider equation. If we were to plug this in, you'd get the resistance of R1 is 100 over the total resistance is 160, times that by the total voltage is 16, and again you will get 10 volts as your answer. So it does work. Make sure that you have the right components multiplied by the right components and divide by the right components. So in this case, do not try and divide R1 by R2, for example, but then take the total voltage. That would be incorrect. It would be incorrect to say 100 over 60 times 16. That would be wrong. If you're going to use the 60 ohm resistor, you need to then find out the voltage across the 60 ohm resistor and use that. Now let's look at parallel circuits. This is a parallel circuit. You can see that there are two branches separate from each other, but both connect to the same ends of the terminal. So you can see as the current gets to this point, it splits. So in this case, you now see that the current gets shared in the parallel circuit, and the voltage across each junction is the same. So if you label these points A, B, C, D, VAB is equal to VCD. And let's say that the voltage here is 16 volts, which means that when it comes back it'll be 0 volts. That means they're both equal to 16 volts. Now there's a law of physics called Kirchhoff's current law. And it states that the current flowing into a junction is equal to the current flowing out of the junction. So if I label this current here as I1 and the currents going through each individual branch as I2 and I3, we know that I1 is equal to I2 plus I3. Let's call the 100 ohm resistor R1 and this other resistor R2. Based on Ohm's law, we know that V is equal to IR, so I is equal to V over R. And I1 is the total voltage of the circuit divided by the total resistance. And that's equal to the voltage across across R1, which is I2, so let's call it V1 over R1 plus V2 over R2. And we know that in a parallel circuit, voltage remains the same. So this is equal to Vt over R1 plus Vt over R2. And if we see here, if we take Vt over Rt equals Vt over R1 plus Vt over R2, we can see that the voltage is cancelled. So you'll get that R1, 1 over Rt, is equal to 1 over R1 plus 1 over R2. And actually, no matter how many resistors you have in parallel, the total resistance, or 1 over the total resistance, is equal to the sum of 1 over the rest of the resistances. So 1 over RT is equal to 1 over each of the resistances summed together in a parallel circuit. And again, this kind of calculation can be very handy and save you a lot of time in questions. So as an example, if you look at this circuit here, if I wanted to find the total resistance, well, I'd first try to calculate 1 over RT, 1 over the total resistance, which would be 1 over 100 plus 1 over 70. And that gives me 17 over 700. So if I wanted to find RT, I just flip that around. I'd say 700 over 17 ohms, which is 41 ohms. So if I wanted to then calculate the current flowing through the battery, I could just say I is equal to Vt over RT, which is 16 volts over 41, and that would give me my current in amps, which is equal to 0.39 amps. And you don't really want to give your answers in a physics exam as fractions. You want to always try to give it as decimal points or integers or whatever. You don't want to leave a fraction as your answer. I advise you to go look at some practice questions in order to help reinforce what you've learned today. It's a good way to understand how to apply the content and the equations. Please make sure to subscribe, like and comment, and feel free to watch any of my other videos in order if that will help you with your physics course, and good luck for your future.